Hi students, we are looking at first chapter of 8th standard mathematics. Okay, this is where we stopped in the last session. Exercise 1.1. Name the property involved in the following examples. Okay, the properties you are well aware of, right? So you can name those properties. Okay, right. Write the additive and multiplicative inverse of the following. Okay, I will show you one or two examples. Additive inverse is this 3 by 5. Okay, multiplicative inverse is what? Is minus 5 by 3. Minus 5 by 3. Finally you should get 1, right? So minus 5 by 3. What about additive inverse? So in this case it is minus 1. Multiplicative inverse is 1 only. Okay, what about the next one? 0. What is additive inverse? Is 0. What is multiplicative inverse? It doesn't exist. Okay, doesn't exist. Exist. Okay, okay, fair enough. Additive inverse here in this case minus 7 by 9. Okay, multiplicative inverse 9 by 7, reciprocal, which makes the multiplication to be unity. Okay, so in this case it is 1. Multiplicative inverse is minus 1. Okay, fill in the blanks. Okay, this part you can easily do, not a big problem. Okay, this is 0. Okay, right. Multiply 2 by 11 by the reciprocal of minus 5 by 14. Okay, we'll do that. What's a big deal in it? 2 by 11, 2 by 11 into, yeah, into minus 14 by 5 is the reciprocal, right? Okay, fair enough. Then what is the answer? Answer will be minus 28. 2 4 8, 2 1 2, 28 divided by 55. So that is the answer. That is the answer. Which properties can be used in computing this? Um, mm-hmm, mm-hmm. 5 will get cancelled out. 2 and 3, 7 by 3 here. 3 will get cancelled out. 4 by 11. Okay. So 7 by 3 plus 4 by 11. There is nothing common here, right? Okay, forget about this problem. Verify the following and write the property used. 5 by 4 plus, okay, associative property, right? Evaluate this after the arrangement. After the arrangement means these two have to be in the at the same place, right? 3 by 5 first, then minus 2 by 5. Okay, plus 7 by 3. This is the rearrangement. Plus minus 2 by 3. Okay, what about the answer? You can ask me what about the answer. 3 minus 2, 1 by 5. Again in bracket 1 by 5. Plus 7 minus 2 is 5. 5 by 3. 5 by 3. So take LCM. LCM is 15. So 3 plus 25. 3 plus 25 is 328. 28 upon 15. This is the answer. Okay. Subtract 3 by 4 from 1 by 3. Like this. 3 by 4 from 1 by 3 means 1 by 3 minus 1 by 3 minus 3 by 4. Like that. Okay. Take LCM. Oh, that is 12. What about numerator? This part is 3. That other part would be would be would be would be would be 9. Okay, nothing but minus 5 by 12. Subtract 3 by 4 from 1 by 3. This is correct. Okay, others you can do similarly. What number should be added to minus 5 so as to get minus 3 by 2? Let's deal it in this way. Add some number x to minus 5 by 8 to get minus 3 by 2, let's say. Okay, this is what we have to do. Now we need to find x, right? Okay, let's find x. How to? Just transfer the other number minus 5 by 8 to the other side. Fair enough. So that becomes 5 by 8 minus 3 by 2. So what is LCM? LCM is 8. So this thing will be 5. Okay. And 2 4 is 8. So 3 4 is 12. This will be 12. So here you will get minus 7 by 8. Okay. So if you add minus 7 by 8, okay, 12 by 8, you will get minus 3 by 2. Is that answer valid? Yes. I just verified it. It's correct. Okay. The sum of two rational numbers is 8. If one number is minus 5 by 6, find the other. Similar thing, minus 5 by 6 plus x equal to 8. You can easily find it out, no problem. If subtraction associate with rational numbers, explain with an example. That also you can do. Subtraction is it associative? I don't think so. Verify that minus of minus x equal to x for these two. Silly problem. Right, the set of numbers which do not have an additive identity. Alright, the set of numbers which do not have an additive identity. Is there any number like that? The rational number that does not have any reciprocal? 0. Yes, the reciprocal of a negative rational number. The reciprocal of a negative rational number is a negative rational number only. Have any reciprocal? Reciprocal of negative rational number is negative only, right? A representation of rational numbers on number line. Gayatri drew a number line and labeled some numbers on it. What set of numbers are marked on the line? These are natural numbers. Sujata said they are natural. They are natural numbers. Parmesh said they are rational numbers. Whom do you agree with? Those are national numbers. Natural numbers, no problem. This is correct. Which set of numbers are these? These are whole numbers. Are they whole numbers or rational numbers? These are whole numbers. Natural numbers plus 0 is nothing but whole numbers. Now, which set of numbers marked on the number line? Can you find the numbers between minus 5 and 3 and on the above line? Can you see any integers between 0 and 1? No. Minus 1 and 0? No. Numbers in the middle of 0 and 1 is off. Middle of 1 and 2 is 3 by 2. In the middle of 0 and minus 1 is minus off. Minus 1 and minus 0 minus 3 by 2. These above rational numbers can be represented on the number line as follows. These are rational numbers. Identify the rational numbers as shown in as A and B marked on the number line. This is 7 by 1 by 7, 2 by 7, 3 by 7. So this is 3 by 7, 4 by 7, 5 by 7. This is 5 by 7, like that. So any rational number can be represented on the number line. Notice that in a rational number, the denominator tells the number of equal parts in which each unit has been divided. The numerator tells how many of these parts are considered. Here unit is 0 to a 1 division 0 to 1 is divided into 7 equal parts. So A is representing 3 out of 7, so 3 by 7. Here B represents 5 out of 7, 5 by 7. Represent 5 by 8 on the number line. You have to make 8 equal divisions. Fifth one gives you 5 by 8. Similarly, represent 20 by 9, 6 on the number line. 29 by 6 is nothing but 4 and 5 by 6. So in between 4 and 5, you have to make 6 divisions, out of which fifth division tells you 29 by 6, gives you 29 by 6. Write the rational numbers for the points labeled with letters on the number line. This is 1 by 5. This is 4 by 5. This is 1. This is 7 by 5. This is 8 by 5. This is 2. Minus 6 by 4. Minus 5 by 4. Minus 1 by 4. Minus 2 by 4. Oh, this is minus 3 by 4. Minus 3 by 4. Minus 1 by 4. Okay, like that. Represent minus 13 by 5 on the number line. That you can do, right? For rational numbers between two rational numbers, observe the following. The natural numbers between 5 and 1 are 4, 3 and 2. Are there any natural numbers between 1 and 2? No. The integers between minus 4 and 3 are these. Write the integers between minus 2 and minus 1. Did you find any? We cannot find integers between any two successive integers, but we can write rational numbers between any two successive integers. Let us write rational numbers between 2 and 3. This method is mean method, average method. If a and 2 are b two rational numbers, then a plus b by 2 is also a rational number between them. That is exactly in the midway between a and b, like that. If you want to find a rational number between 2 and 3, just average it, you will get 5 by 2. 5 by 2 is just in the midway between 2 and 3. Okay, okay, okay. If you want to have a rational number between 2 and 5 by 2, just find an average and you will get 9 by 4. That is exactly in between, in the middle of 2 and 5 by 2. If you want to have again rational number between 2 and 9 by 4, average it and 17 by 8 is just in the midway between 2 and 9 by 4. Okay, then there is another method. Can you write 100 rational numbers between 5 by 10 and 9 by 10 in mean method? You may feel difficult because of the lengthy process. Here is another method for you. Say this is 5 by 10, 6 by 10, 7 by 10, 8 by 10, or in between 5 by 10 and 9 by 10, right? Here we wrote only 3 rational numbers between them. Now if you consider 5 by 10 as 50 by 100, 9 by 10 as 90 by 100, how many you will get? You will get 39 rational numbers in between, right? 51 by 100, 52 by 100, like that. Similarly, when we consider this as 500 by 1000, 900 by 1000 by multiplying with 100, you will get almost 399 rational numbers between this and this, that is 501, 502, 503, 899, all divided by 1000. Okay, so this is the simplest process to get as many rational numbers as you require. Okay, write any 5 rational numbers between minus 3 and 0. This is the example. See what you can write it as 3 minus 3 30 by 10. This is 0 by 10. You can write it as 29 by 10, 28 by 10, minus 27 by 10, minus 2 by 10, minus 1 by 10, lies between minus 3 and 0. You can take any 5 out of these. Okay, or represent these numbers on number line, that you can easily represent these also. Write 5 rational numbers which are smaller than 5 by 6. 5 by 6. Okay, 5 rational numbers. Okay, 4 by 6, 3 by 6, 2 by 6, 1 by 6, 0, 0. Okay, right. Find 12 rational numbers between minus 1 and 2. Minus 1 and 2, what is the gap? 3. 3. 2 minus of minus 1, 3. In this 3 gap, you need to have 12 rational numbers. Okay. If you divide by 4, you will get only 11. So divide it by 5. Okay. That means what to say? What to say? What to say? You need to make the new denominator 5. How to make denominator 5? Minus 1 can be written as minus 5 by 5. Similarly, yes, similarly 2 can be written as 10 by 5. 10 by 5. Alright. Now, okay. Now, okay. Now, now. Minus 4 by 5. My theory. Okay. Minus 4 by 5. Minus 3 by 5. Minus 2 by 5. Minus 1 by 5. Okay. Next 0. Next 1 by 5. 2 by 5. 3 by 5. 4 by 5. 6 by 5. 7 by 5. How many you want? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 8 by 5 also. 8 by 5. 12. Okay. You want, you can also add 9 by 5. Okay. These are the rational numbers between minus 1 and 2. Okay. Find a rational number between 2 by 3 and 3 by 4. You just uh, uh, take LCM. Average method also you can use. Otherwise, see, like what they told, equalize the denominators. Then this becomes 8 by 12. I get. The next one becomes 9 by 12. Is that so? Yes. 4 2 is 8. 3 3 is 9. 8 by 12, 9 by 12. Okay. Now average it. 17 by 24. Right. That is the average. So that lies between these two rational numbers. Find 10 rational numbers between minus 3 by 4 and 5 by 6. You want 10 rational numbers between these two? 10, 10, 10, 10, 10. 3 by 4 I am writing it as minus 30 by 40. Next one I can write it as 50 by 60. Okay. Now I can get as many as rational numbers I want. That is, I can get almost 19 rational numbers between these two, right? Minus 31 by 40, minus 32 by 40, minus 33 by 40. Oh, wait a minute. These are positive numbers, these are negative numbers. So you need not to go up to 10. 5 is enough. So multiply it with 5. 15 by 20. Okay. 15 by 20. No. Wait a minute. Make it like this. 9 is 9 by 12. Okay. This is 10 by 12. This is minus 9 by 12. This is 10 by 12. Here you will get almost 8. Here you will get almost 10. That is minus 8 by 12, minus 7 by 12, minus 6 by 12, minus 5 by 12, minus 4 by 12, minus 3 by 12, minus 2 by 12, minus 1 by 12, 0, 0. Again 1 by 12, 2 by 12, 3 by 12, 4 by 12, 5 by 12, 6 by 12, 7 by 12, 8 by 12, 9 by 12, 10 by 9 by 12. How many you got? Almost 18 rational numbers. Okay, so write any 10 out of them. Decimal representation of rational numbers. We know every rational number is in the form of p by q, where q not equal to 0 and p and q are integers. Let us see how to express rational numbers in decimal form. To convert a rational number into decimal by division method, consider a rational number 20 by 16. Divide the numerator by the denominator. Oh, like this. Continuous division process. like this. Okay, 16 1 just 16, 9 remainder, put a point here and put a 0 here, and then continue the division process. Similarly, 17 by 5. Try to express these in decimal form and write the values. This is 0.5. What about this? Multiply with 4 in both numerator and denominator. This is 0.52. Okay. What about this? 0.064. Okay. This is 197.4. What we observe, there are only finite numbers of digits in the decimal part of the decimal number. Such decimals are known as terminating decimals. Terminating. Non-terminating recurring decimals. Consider the rational number 5 by 3. If you do the long division process, the remainder is always 2. Okay, then this 6 is continuing, never stopping. So this is called recurring. Okay, so only one digit is recurring. Okay, so put a bar on top of the digit which is recurring, 1.64. Now do it with 7. There are so many digits are recurring, 142857. Okay, so put a bar here. Okay, now I express these in decimal form, no problem, you can. Okay, for example, only one digit is recurring, 0.3, or here two digits are recurring, here three digits, here one digit. Such decimals are called non-terminating, and repeating decimals are non-terminating or recurring decimals. The set of digits which repeat is non-terminating recurring decimal is called the period. For example, here the period is 3, whichever the number is repeating, that is called period. Here the period is 75. And the number of digits in the period of non-terminating recurring decimals is called periodicity. Here the periodicity is 1, only one digit is recurring. Here two digits are recurring, periodicity is 2. Here how many digits are recurring? 3 digits are recurring, periodicity is 3. Okay, what is period then? 143. Here what is period? 8 9. Periodicity 2. Think and do to express the following in decimal form. Okay, do that. Which are the aboutting or terminating, which are non-terminating decimals? I can tell you, this is terminating, this is also terminating, this is also terminating, this is non-terminating recurring, this is also non-terminating recurring, and this is also non-terminating recurring. Write the denominators of the above as the product of primes. Okay, that you can do. If the denominators of the above simplest rational numbers has no prime divisors other than 2 and 5, what do you observe? They are terminating decimals. Alright, your observation is correct. Conversion of decimal form into rational form. Converting terminating decimal into rational form. Consider the decimal number 15.75. Find the number of places after the decimal point in the given number. In 15.75, there are two decimal places here. So this can be written as 1570 by 75 by 300. Now you can divide it with a common factor. Okay, see, 63 by 4 is the final form. Okay, without any common factors between the numerator and the denominator. And express each of the following decimals in the p by q form. Okay, 0.35 is 35 by 100 or 7 by 20. This is like this is like this. Okay, converting a non-terminating recurring decimal into rational form. This is quite interesting. 0.4 bar, you can be written as 0.44444, right? Now, what is the periodicity? 1. Now, multiply it with 10. Okay, because only one digit is recurring. So, 10x is this. See, the decimal parts are equal, right? So, now subtract x from 10x. You will not get any decimal part. Okay, so x equal to 4 by 9. So what do you observe? 0.4 bar is 4 by 9, 0.5 bar is 5 by 9, 0.54 bar is 54 by 99, 745 bar is 745 by 999. That is what you will get. Let's see another example. 0.54 bar, how many digits are repeating? Two digits, so multiply it with 100. Now see, the decimal parts are equal, so subtract x from 100x, you will get 99x. Here is 54, x equal to 54 by 99. Another problem, 4.7 bar, so multiply it with 10. So 10x is 47.777, x is 4.777. If you subtract, you will get 9x is 43. So 43 divided by 9. Okay. What is the alternative way? 4.7 bar can be expressed as 4 plus 0.7 bar. 0.7 bar is nothing but 7 by 9. Okay. If you simplify this one, you will get 43 by 9. Anyway, I proceed. Answer will be same. Express the mixed recurring decimal in PQ form. Okay, write the decimal. Two digits are repeating. So multiply it with 100 and subtract. This is what you got, right? Finally, so multiply with 10 on both numerator and denominator. So this is the answer. You can remove the you can cancel the common factors as well if you wish. Think and get right to convert the decimal into rational form. Can you find any easy method other than the Parman method? Yet we have the easy method. 9 by 10 directly. 14 plus 5 by 10. 1.2 plus this is 0.4, right? 1.24 bar. How to proceed? Hey, that is very simple. I will tell you how to proceed. 1.2444. This is what the number is, right? Right. You're not right? You're right. 1.2 plus point four. No. Point 0.4444. Okay. Point 0.4444 can be written as point 4.444 divided by 10. That is 1 by 10 into. Okay. Right. Alright. You're correct. Correct? Yes, correct. Okay, I am correct. 1 by 10 into 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 4 by 9. Okay, this is not equal to, this is equal to, yeah, this is equal to 12 by 10 plus 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 4 by 90. Now equal to 90 as the denominator, numerator 12 nines 108, 108 plus 4 equal to 112 divided by 90. This is the answer. That is what he is saying. Okay. You can remove the common factors as well. You can still reduce it, no problem. So exercise 1.3. We will see the exercise 1.3 in the next session. We will stop it here. Okay. Right. Are you tired of dental problems? Then listen to this. Stop brushing your teeth using plastic brush and chemical paste. Use nature's gifted neem stick for brushing your teeth and stay healthy.